Hello students, in this lecture we will see Supermesh Analysis and the first numerical on Supermesh Analysis. First of all, I will introduce what do you mean by Supermesh. Now if you observe this circuit, there is a current source and this current source is present or it is shared between mesh 2 and mesh 3. So whenever you have a current source shared between two meshes, then these two meshes form supermesh. Okay, that means we can't apply KVL to mesh 2, we can't apply KVL to mesh 2 as well as we can't apply KVL to mesh 3, okay, because they contain a shared current source. There is no problem in applying KVL in mesh 1. Okay, if you see this circuit, there are three unknowns I1, I2, I3. So if there are three unknowns, we require three equations. Okay, and how to get those three equations? The first equation you will get by applying KVL to this mesh. Okay, now two more equations we require. So always remember this thing, super mesh will give you two more equations. And how to obtain those super mesh equations from the super mesh analysis? So from super mesh analysis, the first equation always you will get by looking at the direction of the current source. Okay, so here how will you get the equation? Direction of shared current source. So if you see here, 4 ampere is going up. They have mentioned 4 ampere going up. So here I am writing 4 ampere, I am writing the value, and just for my understanding I am writing 4 ampere is going up. Now this current, can you write in terms of I2 and I3? Yes, I3 is going up through this branch. Yeah, it is moving in clockwise manner, but it is going upward through this branch. And I2 is moving downward. Okay, so 4 ampere is going up, so you have to write down net upward current. And what is the net upward current? So net upward current is I3 minus I2. So this is the first equation from supermesh analysis. So if I write this in nice format, what I will have, it does not contain any I1, so I am writing 0 I1 minus 1 I2, then the coefficient of I3 is 1, so 1 I3 is equal to 4. So I will get this equation. Now how to obtain another equation? As you know that there are three unknowns I1, I2, I3, and you require three equations. One equation we are getting by applying KVL in this mesh where there is no question of super mesh at all. Okay, then two more equation we want from super mesh analysis. Always remember, super mesh analysis will give you two equations. First by looking at the direction of the current source. Okay, now another equation you will obtain by applying KVL to this super mesh. Okay, so while applying KVL to this super mesh, we have to exclude the current source. Okay, so we will move from mesh 2 to mesh 3 and again back to mesh 2. So as if there is no current source, we will assume. So KVL to super mesh by excluding the shared current source. Okay, so here we will see how to apply. Let's say this value of this one is R3, this one is R2, and this one is R4. Okay, so you are aware of that thing. Before applying KVL, you have to assign the sign for the voltages. So I2 is moving over here, so I will assign plus and minus over here. I3 is moving like this one, so plus and minus in this manner. Whenever current enters, positive sign; when it leaves the resistance, negative sign. Similarly over here you will have positive sign, here you will have a negative sign. So I will go like this, I will go move from R3. So naturally when I apply KVL to super mesh, my equation will be minus I2 R3 minus I2 R3. You go ahead, now don't go over here, there is a current source, don't go over here, go ahead, minus I3 into R4. Okay, then you go ahead, don't go over here. Okay, you have to go over here, and then minus R2. Now R2 is shared between these two, so you are traveling this mesh, super mesh, in clockwise manner. So R2, through R2 you are going up, so minus R2, and the net upward current is I2 minus I1, and you have completed this loop, so is equal to 0. So if you solve this thing, you will get another equation in terms of I1, I2 and I3. So this is how you obtain three equation if there are three meshes over here and a super mesh is there. So remember this thing, super mesh is nothing but a meshes that share a current source with another other meshes. Okay, they form the super mesh. Okay. So we'll see for more clarity one numerical. So this is the numerical. Find the current in the 3 ohm resistor. So 3 ohm resistor is over here. Okay, and you have to find out the current using, of course, mesh analysis. If they have not mentioned, we'll prefer mesh analysis. So if you see over here, there are three meshes. So I will assume the currents over here, I1, and I'm strictly saying this thing that never look at the polarity of the sources. Okay, the 7 volt positive is over here, where how we should consider this thing or not. Don't look at the polarity of any sources. You just assume the currents in consistent direction. Consistent matlab either you consider clockwise or you consider anti-clockwise direction. So here I am assuming currents in clockwise direction. Okay, after this, can you apply KVL in mesh 1? So if you go over here, if you travel, there is a current source. That means you can't apply KVL in mesh 1. Similarly, you can't apply KVL in mesh 3 because the 7 ampere is shared between mesh 1 and mesh 3. So they are forming super mesh. Okay, so we'll go for the super mesh analysis later on. First of all, we'll finish this thing where there is a no current source and we can easily apply KVL in this mesh. So I'm writing KVL in mesh 2 first. Okay, KVL in mesh 2. So before applying KVL, you need to assign the sign for the voltages developed across the resistances. So I'm starting at this point, KVL. So minus 2I3, no problem, sorry, minus 2I2, go ahead, minus 3 times I2 minus I3, okay, go ahead, minus 1, I2 minus I1. So we have become expert in applying KVL in a mesh after watching the lectures on mesh analysis. So here you will have minus 2I2 minus 3I2 plus 3I3 minus I2 plus I1 is equal to 0. So this will give me equation like I1, and then I will have minus 5I2 plus 3I3 is equal to 0. If you observe this thing, one can write this in nice format just by looking at this one, and that one will lead to minus I1 plus, sorry, this will be 6I2, right? Yeah, so this will be 6I2 minus 3I3 is equal to 0, and this is my equation number 1. How you can write down this thing easily, or how you can validate this thing? You are applying KVL in mesh 2. Okay, you add all the resistances, 3 plus 2, 5 plus 1, 6. So that will be the coefficient of I2. 1 ohm is shared between mesh 1, and through 1 ohm, I1 is moving downward, I2 is going upward. So currents are in opposite direction. That's why minus sign and minus 1 time I1. 3 ohm shared with mesh 2 and 3. So my 3 will be over here. And current through 3 ohm, I2 and I3, they are opposite. I2 is moving towards left, I3 is moving towards right. That's why minus sign. And there is no voltage source in mesh 2, that's why this is equal to 0. So I'll call this as equation number 1. Okay, now we have to go for super mesh analysis. So I'm writing over here super mesh analysis, and just for your reference I will write over here that super mesh is formed because of mesh 1 and mesh 3. Okay, so now the first part in super mesh analysis. So by looking at the direction of current source, no need to write down this thing, direction of current source, this thing being a first numerical I am writing this thing. So 7 ampere is moving downward, so 7 ampere, and just I will write downward over here. Okay, now we have to write down net downward current in terms of I1 and I3. So I1 is moving downward, but I3 is moving upward. So 7 is nothing but I1 minus I3. Yes, this is the second equation, or rather I will write in a proper format, and this one will give me equation as 1I1 plus 0I2 minus 1I3 is equal to 7. Okay, and this is my equation number 2. Now the second thing, so in the super mesh, so there you have to apply KVL to super mesh. Okay, so first of all we will highlight the path in the super mesh. So mesh 1, so 7 volt, you go over here. Now you go over here, so 1 ohm over here. Now there is a current source. Okay, so don't go over here. Let's say you have to you have to go over here, then 1 ohm over here, and then don't go over here, and you have to complete the path. So I have highlighted that path. So over this you have to apply the KVL. But before applying KVL, you need to assign the sign for the voltages. So here I am writing over here plus minus for 1 ohm. Okay, in the direction of I1. Then you go over here plus minus. Here it will be plus minus over here, and then you complete the path. So 7 volt, 1 ohm, 3 ohm, 1 ohm, and then we are completing this path. This is the path for this one. So I am starting at this point, and I write down the leaving sign. So 7 minus 1 time I1 minus I2 minus 3 I3 minus I2. Okay, you are moving towards right. So towards right means I3 minus I2. Of course, here when you are applying KVL to mesh 1 and mesh 3, you will give preference to I1 and I3, I1 minus I2, I3 minus I2. Such terms will be there. Minus, I have not completed the path here. 1 minus 1 time I3, and then you have completed the path. So this is equal to 0. Okay. So you solve this thing. So 7 minus 1 I1 plus I2 minus 3 I3 plus 3 I2 minus 1 I3 is equal to 0. So you will get minus I1 or 1 I1 plus 4 I2. Okay, and then you will have I3 as minus 4 I3 is equal to minus 7. Okay, and transferring 7 on other side. So this is equation number 3. Okay, when you apply KVL to super mesh, as such you can't write down this equation just by looking at the circuit, as we used to do in earlier cases where we used to apply KVL in a simple mesh where there are only resistances and voltage sources over there. Okay, so there are 3 equations and 3 unknowns. So we'll put these coefficients in calculator. Of course, if you write down the matrix over here, this matrix won't be a symmetric matrix. So here you can see here, this is the resistance matrix. Okay, from equation number 1, I1, I2 and I3, and the right hand side is 0 over here. Here from equation number 2 I am getting 1, 0, minus 1, 7. Okay, and from here I am getting minus 1, 4, minus 4 and minus 7. So you solve this thing, you will get I1 as 9 ampere, I2 as 2.5 ampere and I3 as 2 ampere. Okay, but the problem is not over. You have to calculate current through 3 ohm. Okay, and there is a 3 ohm resistor over here. Okay, so current through 3 ohm. Now you decide how you are moving, towards right or left. Don't look at these polarity. Okay, you have to write down in terms of I2 and I3. Okay, don't look at these polarity. These are the polarities for the voltages. Okay, so let's say if you are decided to move towards right, then it will be I3 minus I2. So I will write over here I3 minus I2 towards right. Now I will substitute the value. So this will become 2 minus 2.5 towards right. Okay, and then this will lead to minus 0.5 ampere towards right. So that means the current through 3 ohm will be 0.5 ampere towards left. If I would have written at the beginning, then it would have been I2 minus I3 towards left. Okay, I2 minus I3, it would have been towards left, and would have directly got the answer 0.5 ampere towards left. So remember this thing. First of all, in supermesh analysis, you will obtain one equation by looking at the direction of the source. If they would have mentioned 7 ampere going upward, then I would have written I3 minus I1. In this numerical, 7 ampere is moving downward, so it is I1 minus I3, and then you have to apply the KVL to supermesh. Now for this numerical, even somebody may say that, can we apply KVL like this one, 7 volt, then 2 ohm, 1 ohm, and can we complete this path? Yes, you can apply KVL like this one. Okay, unless and until you are avoiding this current source and you are applying a proper KVL in a closed path, there is no problem. And the last thing, what is the role of this 2 ohm over here? No role over here in this numerical, because this 2 ohm is present in series with this current source. So this 2 ohm, this is not affecting anywhere in the analysis. So whatever comes in series with the current source, it becomes redundant. Okay. Thank you.